For our next session, talking about the challenges of IoT in Infosec, we are in safe hands with the Chief Product Officer at Radix IoT, Michael Skurla, who has been working in the industry for the past couple of decades looking at things around control automation, IoT product design, particularly around data aggregation, analytics, mission-critical issues, just to name a few. So, without further ado, shall we get started? I'll hand you over to Michael. Thank you.
Thanks. Certainly is an interesting setup, having it right above me. My name is Mike Skurla. I have always been told that, boy, no one wants to listen to a conversation about information security. It's dead true, but within the building space, it's fascinating because it's an area that has been completely forgotten for the most part. Anyone here from the US, just out of curiosity? No? But you've heard of Target, the Target stores? That was probably the most influential breach that started to move into information security within building technologies. And it was not necessarily disclosed exactly what happened for about 3 years. In the end, it was a very simple attack. The vendor itself, a vendor which happened to be a mechanical vendor, had access to a system called Ariba, which was a bidding system for Target. A simple phishing exercise was able to allow something called Citadel access and install into the systems, and then 44 million credit cards were stolen through that transaction. Why I bring this up in the beginning is around the concept that building systems and IT are becoming one. They are merging together. And we have the concept of privacy versus security, how buildings and the IoT system are merging, and then really what is our shared path forward? How does this get resolved over steps? Obviously, this conference has been great. There's been a whole bunch of things that talk about the future and where we're going, and the digital twins conversation is exceptionally interesting. But the fact is, we are integrating things in buildings on a regular basis, and it's increasing more and more. We are becoming part of the IT landscape, whether we like it or not. So what really is privacy? Privacy is the legal, moral, or otherwise imperative topic of not allowing information which is considered privileged, commonly known as PII information, to be released without consent. The best way of assuring privacy is actually to not have the data in the first place. This is the most critical mistake that companies make. Now, I work for a company that focuses mostly within telecommunications infrastructure, as well as smart buildings. I'm owned by a data center company. And so data centers obviously want you to store data. It is their purpose in life, to store as much as you can. And early days in the internet, and even to this day, our goal was to harvest as much as we could. Everyone's heard of the concept, the data lake, which then turns into the data swamp, because you get so much data, you're not actually sure what you're going to do with this. The problem is you've retained it. And what you're going to do with that data, if you don't know, becomes a huge liability and risk to companies. So security protects against this, theoretically. And it is collaborative and systematic, a multidisciplinary approach to this. This isn't just an IoT problem. This isn't just an IT problem, however. Everyone is involved. That Target breach, the one that I mentioned in the beginning, that Target breach was simply an email that was sent out to one of the employees at the mechanical contractor that happened to have a password, and they clicked on it. That has nothing to do with millions of dollars that Target spends on security for their financial systems, their marketing systems, their inventory and logistics systems. This was an email. The problem is they had a password. And it was the most efficient way of a security breach is not through technology, it's through humans. So without security, you have no privacy. There is no way that you can have privacy. So we spend all of this money to try to assure that we have security to improve the privacy. The problem that we have is now that we're introducing more and more devices to networks at an unbelievably exponential rate, we are increasing what's known as the area of the surface attack. It takes one small mistake and you can open everything up. So you look at some of these what seem like minute topics, and they introduce large surface areas of attack. An employee writing passwords down. Anyone watch Ferris Bueller's Day Off ever? Right? How did they get into the record-keeping system? The principal just had a little sheet you pulled out, and it had passwords written down. That alone is a breach that is unavoidable with millions of dollars of technology. Obviously, there are new ways, multi-factor authentication and such, that have improved on that. Open Wi-Fi networks, typing a password into an unsecured website. How many people look for that little certificate in the corner saying that it's got a certificate when you go to a website? Huge risk. A lot of people don't think of it. Leaving your computer unlocked when you walk away. Sounds benign. You're in your office. Yeah, that's actually was the Experian breach. That was a credit reporting agency. Same problem. Left computer open. So it is people. Small flaws lead to large surface areas of attack. Now, there really are two sides to security problems. You've got inbound and outbound. And this is being delineated more and more, in so much as the inbound side is really the focus on the direct harms to individuals. It's your breach of privacy. It is the specific point that you are betraying someone's trust, and there is damage to the organization because of that. There is a more damaging side, though. That's awful. That's actually what happened with the Target breach. It's outbound, and that is the focus on the potential impact now or later that compromises devices and inflicts harm on the internet or other users by proxy. This is the most fastest growing way that breaches are occurring. It's people have no idea. Their information is completely safe. This organization may have thousands of computers that very small bits of information are being assembled into packages that then impact and are being used as weapons to bring down other systems or to simply funnel information and breach the privacy of these other organizations. But it all comes back to you. This is the most petrifying type of breach. Generally, they're very hard to find. They are very easy to exploit and install because it takes any bit of surface attack area to get in. This is also where IoT devices are becoming a serious offender. One of the other presentations talked about the price of IoT devices and the idea that everything is sinking down. You can buy cameras online right now easily for $15. Decent surveillance cameras. The question is, where are they made? What chipset is in them? Are they ever updated? What is the firmware actually doing? It gets even more scary when you get into cloud components of this, because generally a lot of these lower cost companies are creating their own cloud ecosystems for very good reason. They want SaaS revenue, annual reoccurring revenue. So if they can offer a service involving their products, it increases their revenue stream. The problem with this is, of course, that you have no idea where this information is going, how long it's been kept, and these devices are then being mixed with larger systems. Meaning you've created the hole, the gateway, the surface area for that attack to be possible. Now, we have the buildings and IoT side where you start looking at these surface areas in attack, and there are lots of them. It only takes one, and all of these get affected. Notice, though, it's not one discipline that's the problem. I could pick on IoT devices, I could pick on those cameras, and say, well, that IoT device firmware could be a hole and a problem. But it's not. The solution to this is actually systematic. And we're doing a pretty poor job of it right now. Because procurement generally is buying devices and looking for the best deal. We have legacy systems that are out there, particularly when you involve building management systems and other technologies that are in buildings already that were never really meant to be on the internet, but they're bridging into technologies. And you look at all of this, and these are all spaces that are generally different disciplines. So who is responsible now for security? Facility management, procurement, IT itself, sometimes manufacturing, logistics, all the way up to the idea of training and people. The people, in the end, are the problem. No people, no problem. That's been said before in some very bad contexts. But people are generally where the security flaws occur. And companies do not do a good job of training people on the security side of the equation. So devices themselves, given that we have this proliferation of devices, the average building right now, according to ASHRAE, has 12 systems running in it. And you think of that and you're like, that seems excessive. It's not. Elevators, HVAC, lighting systems. There was the conversation about the Edge building in Amsterdam, which is fascinating, and he had a wonderful chart of all of these systems, but that was actually even quite limited. It only showed about 8 or 9. We're dealing with things like plumbing systems now being online. Insulation systems, monitoring and tracking things, mostly for the idea of thermal gain and changing of solar panels, and like all types of crazy things that are playing together. The question, of course, is what connects to the network and how? How do you control the devices? What is the consideration of something between a trusted device and an untrusted device? I said before that collecting data for the point of collecting data is really not a great idea. You should have a point for the data. Given that we are now integrating systems together through APIs, and we're communicating between systems, which, again, from that Edge example is fantastic, it reduces your CapEx expense quite significantly. You look at a meeting room, right? There's 3 sensors doing exactly the same thing in a meeting room. They're saying that someone's in there. One's usually for the HVAC system, one's for the lighting system, one's maybe for a room reservation system. Why on earth are you buying 3 sensors doing the same thing, running 3 wire plants and maintaining 3 networks? So this integration makes entire sense onto the IP backbone. But the downside there is what data needs to be exchanged, and can you spell that out ahead of time to say, can these devices work together? The promise of IP integration is really great. The problem you have with saying that we're going to integrate everything over IP is kind of like saying we all communicate verbally. However, if you start speaking Italian to me, you're still using your mouth. I have no idea what you're saying. And so it becomes a scope that is much larger than it used to be. Who is defining how these devices are integrating together? Who makes that decision? In the practical construction world now, they don't. We're fragmented. There is the notion of master system integrators, and I will openly say that in Europe that is a much bigger part of the equation. It is less fractured because you actually do have the concept of master system integrators. In the US, that is a not prominent thing, except for in some very large construction firms. But it's a very important thing to think about as to how are we going to connect together and what is that essential data that we are going to use to lower our surface area of attack. Notice I haven't necessarily talked about control. I've talked about data, the use of data. There is probably not a time that we will say that you are going to sole source a building from one vendor. In fact, it's probably a terrible idea because lighting companies are very good at lighting. BMS companies are very good at BMS. Mechanical companies are good at mechanical. And there will always be a need to integrate this together. We've made some great strides, particularly in the last 20 years, with protocol compatibility. Even some basic things like Modbus, which, if any of you are from the mechanical world, Modbus is dirty dumb, but consistent. It always, you know how it works, it's basic, and you can integrate things. We then moved into the idea of using things like BACnet, and then of course KNX is another option, though KNX in the US has not become particularly popular. It's growing, but it hasn't taken adoption. But these are the areas where all of this integration can come together with much more cohesion using some of these protocols. But notice, until recently, even BACnet, which just launched something called BACnet SC, which is their secure version, which really is just an upgrade of their IP technology, in the hopes that they can move BACnet outside of just mechanical systems and BMS and into the greater world, somewhat like what KNX has been very successful in doing in other places in the world. Obviously, price is a very interesting thing, and I come from the manufacturing world of making devices. It's sort of what I've always been involved in. As we make more and more devices, and particularly Ethernet equip them, this is becoming a bigger problem. Ethernet chipsets now are within a couple of dollars. Just 8 years ago, if you were going to deploy Ethernet into a device, the chipset would have cost you around 18 US dollars. So this actually makes it very attractive to be on an IP backbone. But every device that you add introduces a new risk and a new vector of attack, particularly since it's software. Now, there is IoT standards at the moment. Does anyone know of any? No. There hasn't been much standardization, and most government agencies have avoided this topic like the plague, which is probably for the best. But there have been several standards that have, I guess, gotten drafted, one in Canada, several in the United States, including one in California, which is usually the most progressive. The European Union has been looking at it, but everything to date has been exploratory, which means it puts the onus on the manufacturers and the systems designers to take a careful look at the security of what is being deployed. Design. So when I talk about these master system integrators, and I talk about the IoT side of the equation, everything is an IoT device. Whether that's a computer, whether that's a Wi-Fi network, and the cell phone that you're on right now. Everything is a device. And the question is, how many layers can you put in to reduce that attack surface enough to slow the penetration ability of that surface? You're never going to completely stop it. But you can make it to the point where it makes it exceptionally difficult. And just like any arena of theft or crime, it is the easiest point of entry will be exploited, and if they can't get in quickly, they'll move on. Now, there are very, very elaborate worms, especially out there right now, that are winding up in ecosystems in the computer world. But there is also virus protection software. As long as you're following layers that you can get to, it puts buildings in a much better realm. The biggest fear right now, and this was published by ASHRAE, was legacy systems that are in buildings. Because let's be honest, people are not stripping buildings and replacing their BMS systems. The return on investment is actually quite low. So the idea of adding a layer on top is what's becoming more and more popular. You have an existing infrastructure. You have a highly insecure infrastructure in buildings in general, with all of these separate subsystems. So what can you do to say, great, instead of saying that we're going to access all of these, the data's been there for decades, let's pull this together. Let's pull it together, and then using IoT platforms and frameworks, you can say you have a single point of entry. This is probably the most effective and secure way of getting into security within a building. It's also the most practical. How do we improve our situation in the last minute that I have, or 30 seconds? Industry trust mark programs. This is something that various industries are trying to gather together and seem to be doing very successfully to show that they have some level of certification. Minimal viable policies within organizations is helpful if you have an organization that's large enough. And then interoperability expectations between industries, probably the hardest. If, as manufacturers and building technologists, we can't sort this out in the next couple of years, governments will start doing it for us, and it probably will not be super great, both for the user or for the manufacturing sector. I know I'm out of time. I talked about a lot of this stuff already. 20 minutes is short. That is the end. Are there any questions? I know there aren't a lot of people in here, but this is a lot to cover. I teach some classes on security, and I really tried to cram a bunch of this stuff in. The inbound and outbound relationship, I would say, is the most important thing to understand out of this, and there's a ton of books that are on this right now. There aren't a lot of answers, and it really involves everyone to solve this in system design at the moment. That's it. Thanks.
Thank you very much.